Hi, it's Miss House. I have posted a challenge problem for you in my math lab, and I want to go over the problem with you to talk about some of the things that students experience when they're doing problems like this. You can look at the way it's done in my math lab. It's a slightly different approach, but it's all of the same principles. The first thing I want to point out to you here is that when students are working a problem, they make assumptions that are not true. Okay, for example, if you look at angle P, which they're asking us to find here, the measure of angle P, given that these are parallel, it looks like a 90-degree angle. But unless there's a square in the corner, right, you cannot assume that that's a 90-degree angle. So you have to watch out for students having assumptions about things that aren't really true. And this happens at all levels. Now, while your kindergarteners or first or second grade students are not going to do problems this complex, it just shows you that there are times when students at all levels make assumptions that aren't true, and that's going to be your job to point that out, that that's not true because there's no square drawn in that angle indicating it's a right angle. Another thing that students may or may not do is come to you with the knowledge that they need to do a problem. So I've drawn a couple of pictures, or 3 pictures here, to show you the kinds of things that we're going to need in order to solve this problem. And you'll notice that none of these are in the original picture. Okay, so I'm going to show you what those principles are, and then you keep in mind when you're working with students that there are things that you may assume that they know that they may not know. So you want to go over background information with them. So if I were teaching this, say, to a middle school class, maybe even a 5th or 6th grade class, I would first talk about alternate interior angles. We know that parallel lines are 2 lines that never intersect, and that if you cut those lines with a line, it's called a transversal. And that the alternate interior angles, that's interior, that means in between the 2 parallel lines, okay, those alternate interior angles are going to be congruent. So I'm going to put a little star on what I know are the alternate interior angles. So that one and that one, right? This angle here and this angle here are alternate interior angles. We could also say that this angle and this angle are alternate interior angles. Those are the angles that are on the opposite side of the transversal inside the parallel lines. Okay, and the same could be true over here. It doesn't matter which way your transversal is slanted. Okay, so that's the first thing we need to know, that these angles are alternate interior angles and that they are congruent or have equal measure. Now, the next thing we need to know to do this problem successfully is that the angles of a circle, okay, if you were to add up all the angles in a circle, so you don't see any angles drawn, but there could be an angle here, assume that goes to the center, and an angle here, and an angle here, and an angle here. All those angles have to add up to 360 degrees. So in a few minutes, we'll need to use this concept as well as this alternate interior angle concept. So first thing we know is that students have assumptions that may or may not be true. The second thing we know is that there are prerequisite skills the students may or may not have, so a little review is important. And the third thing is that, especially when doing visual problems in geometry, some things are true that you don't see on the original figure. Okay, for example, if I want to do this, I don't see alternate interior angles, so I have to think about this for a few minutes. So what I'm going to do is I am going to draw a line through P that is parallel to AB and CD. And then I'm going to extend this line And actually that's a ray, right? But let's extend it in this direction. Okay. And now look what I have. I have alternate interior angles. So now I know that this angle inside these two parallel lines is 137 degrees. So I'll mark that with 137. And keeping in mind that I want to use proper notation, I will put the degree mark with that 137 degrees. All right, those are alternate interior angles. And we wouldn't necessarily be able to visualize that unless we add that figure, that parallel line in the middle. All right, so now I know this angle. Well, I have another line here and another parallel line at the top. I'm going to extend that parallel line at the top, okay, so that that looks like I've got these two parallel lines cut by a transversal, meaning these alternate interior angles are equal. Now, that's not P. P is this angle, APC, on the inside, okay? Remember, the vertex names the angle on the inside, so I'm just going to erase that P for now, keeping in mind that what we're trying to find is this angle on the inside. The angle over here on the inside that's alternating with this 125, okay, is an alternate interior angle, so that's 125 degrees. So I will type in 125 degrees for that angle. And I'll put it in the right place and mark it with a degree symbol. Okay, so now comes the part where we need to find angle P. So I'm going to erase that line that I added. Get rid of this line. Don't need this line anymore. It's helped me to see those alternate interior angles. And what I'm going to do now is I'm going to draw a circle with that vertex P at the center, right? This is a circle right here. And guess what? The three angles in this circle have to add up to 360. So these three angles, and the third one being this unknown angle we're trying to find, P, have to add to 360. So if you were doing this in the context of an algebra class, which you probably won't be doing, but you could be if you end up teaching a fifth grade class at some point, or maybe you move up to middle school at some point, I need to add these two numbers together. Okay, so 125 plus 137, and here I would talk about if you add the 5 and 7, you get 12, and you have to carry your 1, so I'd put a 1 up here. Okay, so let me carry my 1. Then I add 2 and 3 and 1, that's 6. Try that right on here. And then I add 1 and 1 is 2, so that's 262. Okay, so that's the measure of these two angles that are here, and these two together with angle P, so 262 plus angle P has to be 360. So we have 262 plus P equals 360. And now to find my answer, we could talk about, we need to subtract that 262 from 360, right? So I'll do minus 262 on this side of my equation, and minus 262 on this side of my equation, and I'll end up with the value of P is, right? And so here I would have to talk about borrowing, okay? If I don't have a calculator, I've got to say that that's a 10 minus 2 is an 8. And then I've borrowed from the 6. It's now a 5. A 5 is not enough. I have to borrow from the 3. So it's a 15 minus 6, which is 9. So the measure of angle P is 98. And so that's the approach I would take for this problem. Let's review some of the things that are pertinent to not just your knowledge of geometry, but of teaching. And that is that students make assumptions, Like here, they might assume that's a 90-degree angle, right? Students may lack the prerequisite knowledge, so you want to go back and talk about what do they need to know to solve this problem. So I reviewed transversals and the angles within a circle for you. Students have a hard time thinking about things that they have to bring to the problem. Like I had to add this parallel line to visualize my alternate interior angles. And then I added a circle. So those are the kinds of things that, whether it's in geometry or reading or English or social studies or whatever you teach, those are the kinds of things that you will need to think about. So I encourage you to go try the challenge problem. And if you have a problem or have any trouble with it, just post that to the discussion board.